Okay, so we have a new topic. We're going to be talking about something called rational expressions. So I just wanted to state what the learning goal is for this particular video. What we're going to be doing is we're going to be looking at something called algebraic rational expressions. And our goal is to be able to simplify those. And you'll see what that looks like in a minute. So by the end of this video and a couple of the videos that follow, you should get a good grasp on this. And there's a rubric attached here so you can kind of get a really good idea about what you should be able to do once you're finished watching these videos. So when you come to class, there will be some checkpoint questions, and you can pause the video and read these 4 stages that you should be at. And what we're trying to get you to is that D level where it says that you can successfully complete all the checkpoint problems with no assistance. You don't have to ask a friend. You don't have to ask me. So that's where we're trying to get to. Okay, so we'll take a look at the content, and then when you do the checkpoint problems, you're trying to get there. Okay, so here is the first statement. Okay, so what we're saying a rational expression is a fraction that contains polynomials in the numerator or the denominator or both. Okay, so we're going to go back and we're going to forget about polynomials for a second, and we're going to say, well, how does this work when we're dealing with just regular fractions? So instead of polynomial fractions, we're going to deal with just regular old numbers. So we know that if we simplify 12 over 18, most people would be able to tell me that the correct answer to this simplified is just 2/3. But I always ask the question, why is it 2/3? And a lot of people do it so automatically that you never really stop to think about what you're doing. And so here's what you're really doing when you're simplifying 12/18. You're saying that 12 can be turned into 2 times 6, 18 can be turned into 3 times 6, and whenever there's a common factor at the top and the bottom, I can divide those. The 6's cancel. And here's the 2/3 that you kind of just know, but you've never really thought about factoring. But what you're really doing is factoring the numerator and the denominator into 2 parts, and then simplifying those parts. Okay, so same thing over here with 14 over 16. I can say this is 2 times 7 on top, and that 16 is 2 times 8 on the bottom, and the 2 on the top cancels the 2 out of the bottom, and 7/8 is what you know the reduced version of 14 over 16 to be. Okay, so that's really what our goal is going to be. To simplify any fraction, you're factoring the numerator, factoring the denominator, and you're canceling one matching factor on the top with one matching factor on the bottom. Okay, so if I give you this problem here, okay, if we scroll down a little bit, something like b minus 1 over 5b minus 5, your goal is the same. This is a fraction, just happens to have some polynomials in it, but it's still a fraction. So your goal is going to be factor the numerator, factor the denominator, and if there are any matching factors, you're going to be able to cancel one on top with one on bottom. Okay, so let's take a look at what happens with this first example, b minus 1 over 5b minus 5. Okay, so what I'm going to do is I'm going to say, well, b minus 1, how do I factor that? And since that's a linear binomial, which means there's no exponents here but 1, I can't do any factoring for the numerator. So I'm just going to say I can't really do much with that. I'm going to leave it the way it is. But the bottom, I can factor because they both have a 5 in them. So I can say the bottom turns into 5 times b minus 1. Okay? And if you notice, there's now a b minus 1 on the top and a b minus 1 on the bottom. I can cancel out this whole expression with the whole expression on the bottom. Both of these are gone. Okay, so you're probably wondering, well, look, there's nothing on top. What's the correct answer? Some people might say, well, it's 5. But remember, 5's in the denominator, so it's really a 1 up here, 1 over 5. And I'd say this simplifies just down to 1 over 5. And that would be the simplified version of this expression. Okay, so let me just make a side note before we look at the second problem. You can't cancel out, if you see a b on top and a b on bottom, you can't just say, I'm going to cancel out this little piece with this little piece. Okay? The idea here is we can only cancel factors, okay? Factors on the top and factors on the bottom. And I would say this b is in a difference with the 1. It's not a factor with the 1. So I can only cancel out factors, which means it would have to be by itself. Okay? So that's why I was able to do it over here, because I could say b minus 1 is a factor, and then the b minus 1 on top is a factor as well. Okay? So you'll see that as we go. Can't cancel out just little parts of addition and subtraction problems. It has to be the whole thing. Okay? So here's your second problem. Okay? Again, we're going to try to factor this numerator. I'm going to say, well, let's see. 26 has a 13 in it, and if I check 91, that also has a 13 in it. So let me factor those out. So I'm going to say 13. Oh, wait, I see a C as well. This has 3 C's. This has 1. So I can take out 1 C. Okay? And then I'm going to see what's left over. Well, 13 to get back to 26 is a 2. And I had 3 C's. 1's out here, so I got to leave 2 inside. Well, 13C to turn into 91, that looks like times 7. Okay? And then on the bottom, I have one of these as well, 2c squared plus 7. This one doesn't factor, right? There's no common factors between 2 and 7. There isn't a c in common, right? So that's as factored as this one gets. But if you notice, 2c squared plus 7, and I have another one on top. Okay, so if you see the difference between this one right here where the 5 was on the bottom and I said 1/5, 13c is on the top, which means there's technically a 1 on the bottom when everything cancels. 13c over 1, I can just say, well, this all just turns into 13c. Right, so this big expression here, this big fraction, is really just the same thing as 13c. Okay? Let's take a look at a couple more examples using some different kinds of factoring. Right, so if you take a look at this one on the left, okay, the top I can say, well, GCF again, there's that 3 in common. So I'm going to take that out. It looks like d minus 2. Okay? And then on the bottom of the fraction, there is no GCF, but now I have this quadratic trinomial, and we had a different way of factoring these. We said if you can find numbers that multiply to -6, the same numbers add up to the +1, you're going to be able to break that up into 2 binomial factors. Okay? Both of them are going to have a d in the front. Okay? So this 2d, the d squared is being split up like that. And then I'm saying, well, what numbers multiply to 6 and add up to 1? Well, that looks like +3 and -2, and those would be my factors. Okay? So again, if you take a look, I have an entire factor on top, d minus 2, that cancels out with an entire factor at the bottom, another d minus 2. So that leaves me with 3 on top, and again, d plus 3 on the bottom. And I'm going to keep saying this so that you don't do this when you get to your problems. You cannot put a cancel through a 3 here and a 3 here, because I'm not going to say that this bottom 3 is a factor. It's a sum, and I can only cancel factors. Okay? So I got one more. Factoring the top of this one is a little bit strange. This is a difference of 2 perfect squares. Remember, I can write 4 as 2 squared. Right? So because this is a difference of 2 perfect squares, I can write that as 2 plus e and 2 minus e. Okay? And when I look at the bottom, I see 7e minus 4. Well, that doesn't really factor with anything. Right? So what I'm seeing here is an example where I factored the numerator successfully, 2 plus e, 2 minus e. On the bottom I have 7e minus 4. That's as factor as that gets. And I don't see any matches here. Right? I can't cancel out this with anything on the bottom. 2 minus e doesn't cancel with anything on the bottom. So it looks like this is as simple as it gets. This would be something, if I was going back to regular numbers, if I did something like 15 over 17, and I said simplify this, you'd say, well, 15 and 17 don't have any factors in common except 1, right? So there's really nothing that I can cancel on the top and on the bottom. And that's what we have going on here. So this would be a reduced fraction. I would say, see this thing right here? It's not nice, but that's as simple as this gets. I can't simple it down, make it look any simpler. Okay? So you're going to see some examples that look like this as we go along, and your job is find factors, okay, and cancel out 1 for 1. Okay, so when we're looking at our learning goal, right now at the end of this, you should be able to simplify algebraic expressions. I'm going to add a little something on here by factoring. Okay, so we're going to factor out those common parts, and we're going to cancel them out for all these problems.